All right, silly people, here's the situation. Uh, we're just looking at a baseball that is flying through the air, um, and we're discussing what its velocity would be if the quadratic um, air resistance was equal to the linear air resistance. Um, and we're doing that for a baseball of diameter 7 centimeters and one of 70 centimeters. And we're going to be using this equation here, which is the ratio between um, the quadratic friction force and the linear friction force. Um, so if we're setting the quadratic friction force equal to the linear friction force, then this ratio is 1. So we're setting 1 equal to 1.6 times 10 to the third seconds per meter squared times dv. So we can solve for velocity as being 1 over uh, 1.6 times 10 to the 3 times d, which means if your baseball has diameter of 7 centimeters, it will be 1 over 1.6 times 10 to the 3 times 0.07, which is about 0.009 um, meters per second. Yeah, about 0.009 meters per second. Um, and then if you set your diameter then to 70 centimeters, uh, then you get slightly larger. Um, yeah, actually, no, you get a slightly smaller um, velocity of 0.0009 meters per second. So quite small there. Yeah, quite small. Um, so for small velocities, it can be assumed that the quadratic friction is equal to the linear friction force. Um, and then we're also asked to find what is the reasonable range of velocities where the um, friction can be treated as entirely quadratic. Um, so I think a good way to describe this is if the ratio between the quadratic and linear friction forces is about 100 or greater than or equal to 100. In that range, you can treat the um, friction as being entirely quadratic. So you can use that as our um, ratio. So putting that into the equation, um, 1.6 times 10 to the 3 seconds per meter squared um, dv should be greater than or equal to 100, and then solve for the velocity. So velocity is going to be greater than or equal to 100 divided by 1.6 times 10 to the 3 seconds per meter squared times the diameter. If you're looking at the 7 centimeter baseball, then it's going to be greater than or equal to 100 over 1.6 times 10 to the 3 times 0.07, uh, which is about now 0.9 meters per second. So um, now that's an actual like speed. It's quite fast now. And then if you look at the 70 centimeter diameter baseball, you're doing 100 over 1.6 times 10 to the 3 times 0.7, which is going to reduce by an order of magnitude. So it's going to be 0.09 meters per second. So so 10 centimeters per second, pretty much. So yeah, those are your velocity ranges.